Welcome to Lesson 2.4, Parts and Total Number Stories. In this lesson, our objective will be to solve number stories using parts and total diagrams. Here are some tips that can help us solve word problems. Step 1. What do you know? Every story problem gives you information that you already know. Step 2. What do you want to find out? This is usually the question in a story problem. There's always something that we're asked to figure out. Step 3. What will you do? Draw a picture, use tally marks, maybe use adding, subtracting, multiplying, dividing, or draw a diagram. Step 4. Once we figured out a way to help us solve the problem, we need to answer the question. We also need to make a number model. This helps show our thinking. An example in parentheses of a number model is 84 plus 32 equals 116. Step 5. Check. Does the answer make sense? How do you know? And remember to write the unit. Look for keys in word problems. Keys are key information that can help us figure out what to do. If you read sum, altogether, total, plus, in all, these are key words that tell us we need to add. Looking now at the bottom half of the screen. If you read how many more, this is tricky. How many more? Sometimes kids see that word more and they think they need to add. But sometimes it means you need to subtract. If I say Mrs. Gonzalez has 3 pencils and you have 1 pencil, how many more does Mrs. Gonzalez have than you have? I would need to subtract those two numbers to find the difference or to find the answer. Other keywords that can help us know we need to subtract are less than, fewer, minus, difference, and remainder. Let's solve one of these story problems now. 2 pythons laid clutches of eggs. Clutches are similar to nests. One clutch had 36 eggs. The other had 23 eggs. How many eggs in all? Step 1, think about what we already know. We know that one clutch has 36 eggs. We know the other has 23 eggs. Step 2, think about what is it I'm trying to figure out. I'm trying to figure out how many eggs in all. Ooh, notice we have one of our key words here. In all. That tells me I will need to add. Step 3, figure out what we're going to do to solve this problem. We're actually going to use a diagram. The diagram down here is called a part-part total. In this kind of diagram, you have 2 parts of information that will add up to a total. We're going to go ahead and fill in this diagram now. Part of the information we already know is there are 23 eggs. Another part of the information that we know is there are 36 eggs. We're trying to figure out the total, so we can put a question mark here. The unit that we're counting is eggs. Now that I have a plan, I want to go ahead and do step 4, solve the problem. I know that I have this key word that said in all, and it tells me to add. My 2 parts here are going to add together to make a total. I'm going to show my work off to the side. 23 and 36. I'm going to put a plus sign to show that I'm adding. I'm going to start on the right side. 6 plus 3 is 9. 3 plus 2 is 5. Okay, my answer is 59. I'm going to go ahead and write a number model to show my thinking. 23 plus 36 equals the total of 59, and my unit, that's very important, eggs. My last step is to check, does this answer make sense? Would it make sense for me to have an answer of 59? I'm going to use estimating here. If I have about 20 eggs and I'm adding a little over 35 more, it would make sense for me to have an answer in the 50s of eggs. If I only had 1 here, something would be very wrong. 20 and 30 would not give me an answer of 1. 59 is a reasonable answer for this problem, so that's okay. We're going to go ahead and move on to our next story problem. An alligator clutch had 50 eggs. Only 15 eggs hatched. How many did not hatch? Okay, let's think about what do we already know. We know an alligator clutch had 50 eggs. We also know only 15 hatched. We want to find out how many did not hatch. This kind of problem is tricky. It actually gives us the total first, okay? So we have a total up above of 50 eggs. That's how many eggs there were all together. For this kind of problem, the diagram's helpful, but so is a picture. I'm going to go ahead here and draw an imaginary clutch. I know that inside this clutch there was a total of 50 eggs. Okay, then I'm going to read over here, only 15 eggs hatched. Okay, that's part of my information. I'm going to put 15 here. Okay, if I think about this, I'm going to draw my nest here. I'm going to draw off a part. Okay, inside this part are the 15 eggs, and these 15 eggs actually hatched. What I need to figure out is what part over here did not hatch. Here's my 15, and some of these eggs over here out of the total of 50 did not actually hatch. This is where my question mark's going to go. My unit is still eggs. Now that my information is sorted out, I need to figure out what to do. What I want to do is find the difference between the two numbers. This means I need to subtract. I want to take the total eggs in the whole clutch of 50. And then I want to take out the eggs that did hatch. 15 did hatch. I want to take them out. What that's going to do is tell me the part over here that did not hatch. So I'm going to write this now another way that will be easier for me to solve. 50 minus 15. There's lots of ways to solve subtraction problems. I could think to myself, 50 minus 10 would be 40, and then minus 5 more would be 35. Or I could subtract and make some trades. I could do 0 minus 5. Oh, wait a minute, that's not possible. If I have nothing, I can't take away 5. So I would have to make a trade. I'm going to go to the tens place and take 1 away. Now instead of 5 tens, I have 4 tens. That 1 10 I took away, I'm going to give to the 0, and it now becomes 10. 10, now my number is nice and big. 10 take away 5 is 5. 4 take away 1 is 3. I could also have counted up from 15 up to 50 to find my answer. So my answer then is 35. Now I want to think about 35 what? This is 35 eggs that did not hatch. My last step is to think about, does this answer make sense? One way to check your work for a subtraction problem is to add the two bottom numbers together to see if you get back to the top number. Okay, that means you would have solved it correctly. So what I'm going to do is rewrite it over here. If I take 35, that was my answer, and I add 15, I should get back to the number 50. 5 and 5 is 10. Carry that 1, 3, 4, and 5, and notice it checks. We arrive back at the same answer. This tells me I did my work correctly. One more problem. A queen termite laid 4,000 eggs on Tuesday and 7,000 eggs on Wednesday. How many eggs did she lay in all? We're going to think about what we know. We know that there's 4,000 eggs laid on Tuesday, and she laid 7,000 eggs on Wednesday. We want to think about, what do I want to know? That's right here in this question. How many eggs did she lay in all? Again, I have these key words, in all, so I'm going to be adding. Now I need to organize this information into my diagram. I'm going to write 4,000, that's part of the eggs that she laid on Tuesday. And I'm going to write 7,000, those are the part of the eggs that she laid on Wednesday. I'm going to put a question mark for total. This is what I want to find out. My unit is eggs. My information is organized. Now I need to think about, what do I have to do to solve? Remember, we had those key words, in all. This means we're going to add. I'm going to take 4,000 and add that to 7,000. Think about our fact extensions. We know our basic fact of 7 plus 4 is 11. And now I know I'm working with thousands, so I can add my zeros on. 3 zeros symbolize thousands. So my answer is 11,000 eggs. Want to think about, does this answer make sense? Would an answer of 11,000 eggs make sense for this type of problem? This answer does make sense. We're starting with 4,000. We're adding on 7,000, so we should have an answer in the thousands. We're adding two smaller parts of 4 and 7, and we arrived at a larger part of 11,000. So this answer makes sense. If I had had an answer of maybe 100, that would not make sense. 4,000 and 7,000, and then if we had ended up with an answer back in the hundreds, I would know I need to recheck my work. That would not make sense. But our answer of 11,000 does make sense. Time for you to show some of your work and for you to practice. Please take out your math notebook. Here is quiz question number 1. A green turtle laid 100 eggs. 45 eggs did not hatch. How many eggs did hatch? Be careful here. All right, you're going to make a part total diagram. You're given, I'll give you some clues, you're given a total. Part of that total did not hatch. Your job is to figure out the other part that did hatch. Quiz question number 2. This is your last quiz question for today. There's only 2 because these are story problems. A giant toad laid 1,000 eggs on Thursday. The same toad laid 6,000 more eggs 1 week later. How many eggs were laid in all? Again, you should be drawing a part total diagram and solving the problem. After you finish these problems, please take the quiz and put your answers into the quiz. Have a great evening, and I will see you in class tomorrow.